Part 2 of Chemistry, Chapter 1st, Matter. So if you want to listen the Part 1, I have given the link in the description, so you can simply watch from that link. So shall we start? The kinetic theory of matter. The kinetic theory of matter explains the behavior of the three states of matter. What kinetic theory of matter explains? That the behavior of the three states of matter, that what type of behavior they have, and that is summarized below. All matter is made up of very tiny particles called molecules. As we know that all the matters are made up of tiny substances called molecules. In the solid state, the particles are rigidly held in the positions about which they can only vibrate. So in a solid state, the particles are tightly packed in their own positions in which they can only vibrate rather than moving. In the liquid state, the particles are in continuous motion but are not completely separated from each other. While in the motion, they collide among themselves. So, in liquid state, that the particles are in continuous motion, but they are not completely divided from each of the particles. And while they are in motion, they collide among themselves. And in the gaseous state, the particles are in continuous random motion and they are almost independently of each of the particles. That they can move here and there independently. The particles in a gas travel much longer distances than in a liquid before they collide with the other particles or with the walls of the vessel. Here we understand that in gas the particles travel much longer distance, very long distance the particles travel in a gas and before rather than in a liquid, and before they collide with other particles or with the walls of the any vessel. The collision of the particles with the walls of the vessel give rise to the pressure of the gas. What gives rise to the pressure of the gas? The collision of the particles with the walls of the vessels give rise to the gas pressure. The particles possesses some energy due to their motion. The energy is called kinetic energy. Here they define that what is kinetic energy? The particles possesses some amount of energy due to their motion of them. So that is called kinetic energy. That short form is Ke. The Ke possessed by the particles is dependent on temperature. So the kinetic energy possessed by the particles, they are dependent on temperature. The higher the temperature, the higher is the Ke, and the lower the temperature, the lower is the Ke. So when the temperature is higher, then kinetic energy will automatically higher. And when the temperature is lower, so Ke is lower automatically. Then how kinetic theory explains the interconversion of states of matter. Here we will study that why and how kinetic theory explains the interconversion of states of matter. First, solid to liquid interconversion. Solid to liquid. The particles constituting a solid only vibrate about their mean positions. Here is meaning that a particle is said to be solid when a substance only vibrate about their mean positions rather than moving here and there. As the solid is heated, the Ke of the particles increases. As we know that when we heated a solid, the kinetic energy of the particles increases, and because of rising of temperature, the particles vibrate more and more vigorously till they move away from their fixed position. So with the rising of the temperature, the particles of a solid vibrate more and more vigorously till they move away from their fixed position at a particular temperature, meaning till they become a liquid. So this process is called the melting point of a solid. Thus, a solid becomes a liquid. So, by this process, a solid, by heating the solid, what solid becomes? Liquid. Then liquid to solid. As the liquid is cooled, the K of the particles decreases. So, when the liquid is cooled, the kinetic energy of the particles of liquid will decrease, and the particles move shorter and shorter distance as the temperature is lowered. So when the temperature is lowered, particles move shorter and shorter distance rather than longer distance. At the freezing point, the translatory motion of the particles ceases and the particles get rigidly fixed. So when the translatory motion in the freezing point, the particles ceases and the particles get hardly fixed. This is how a liquid changes into solid. So this is the process that how a liquid changes into solid, that liquid becomes a solid. However, the particles in a solid continue to vibrate about their mean positions. So a solid continue to vibrate about their mean positions. So second number is liquid to gas interconversion. First, liquid to gas. The particles in a liquid are in continuous motion, during which they collide among themselves. So, the particles in liquid state, all particles are in continuous motion, during which they collide among themselves. If they collide strongly, some of the particles may overcome the attractive force and escape. So, when the particles will collide strongly, some of them may overcome the attractive intermolecular force and escape. A liquid evaporates in this manner. So in this manner, the liquid evaporates. As the temperature is raised, the Ke of the particles increases. So automatically, when the temperature will higher, the kinetic energy of the particles will also be increased, and the particles collide more strongly with each other. This leads to faster evaporation of the liquid. So, evaporation of liquid becomes faster by this process. At the boiling point of the liquid, the Ke of the particles becomes so great that all the particles tend to escape. Thus, at the boiling point, the entire liquid may turn into vapor. So, this is called the boiling point, and by this process, the whole liquid turned into vapor. Then is gas to liquid. In the gaseous state, the particles move very fast independently of each other. So in gaseous state, the particles move faster and faster, and they are also independent of each other. As the temperature is lowered, so when the temperature is lowered, the kinetic energy of the particles will also automatically lowered. So when lower energy gaseous particles collide with each other, they may form bigger lumps or clusters, and the gas may condense into liquid. So in this process, the gas turns into liquid. Here we will study that the conditions of a state differ from substance to substance. So here they tell that a liquid freezing at 0 degrees Celsius. At what temperature the liquid cools? At 0 degrees Celsius. And the boiling point of water is 100 degrees Celsius. And a particular boiling point of ethanol is 78 degrees Celsius. In fact, the melting and the boiling points of the characteristics of a substance, and you can identify the substance by determining these points. So, how we can determine this substance? Identify this substance by the melting and the boiling points are characteristic of the substance. So, in this way, we can identify the substance by determining these points. In other words, the conditions of the change of state differ from substance to substance. So, in other words, we can say that the conditions of the change of state differ from substance. How they differ from substance to substance? This is because the intermolecular force and the intermolecular space differ from one substance to another. That a particular particle's intermolecular force and space differ from one substance to another, and they are not constant. So guys, this is the end of the part 2, and if you want to listen the part 3, so please subscribe and like my channel, and I will discuss more explanations of further chapters and further parts. Thank you guys for watching.